Today's notes are on 5.1 rational exponents and properties of exponents. If we are given, this is called a to the m power. So the base is the a value and m is called the exponent or the power. So basically this is going to be the base. And then right here when it's raised to the very, very top, this is called either the exponent or the power. Okay, you can write that. That's the exponent or the power. So wherever I refer to the, like right here where it says 3 to the 5th, 3 is called the base, 5 is called the exponent or the power. The m tells you how many base numbers are being multiplied together. So like on this one, how it says 3 to the 5th power, that means it's going to be 3 times 3 times 3 times 3 times 3. That's the way that is going to be written. So you're going to write the base 5 times. On this one, how it says x to the 4th power, you're going to write x 4 times. And that's all going to be multiplied. So that's x times x times x times x. So there's 1, 2, 3, 4 of them. And that's all going to be multiplied. Now, to use a calculator here, to type in 3 to the 5th power, you can type in 3 times 3 times 3 times 3 times 3, but that's just going to take long. So using a calculator, I'm going to go ahead and type in the number 3. That's my base. Now on this calculator, that's the raise key. So that's basically now I'm going to put an exponent and now I'm going to hit the number 5. And that is equal to, let me go ahead and let me change my settings real fast. Sorry, that was on scientific notation. Let me go ahead and change it. So it's 3 raised to the 5th. So that's 243. So this answer right here is going to be 243. Now, let's say you have this calculator right here. Now, on this one, there's the raise key right there, okay? So I'll be hit 3 raised to the 5th power. And on this one, it actually shows that that's going to be an exponent. It actually shows that it's higher. Or on this one, it doesn't, but that's still fine. Sometimes you don't have that key, that little raise key. Sometimes you'll have a y to the, it'll be like y raised to the x or x raised to the y. That's the key that you'll end up using. Do not try doing this one right here where it's x, 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 x. X is a variable. It's not an actual value. I didn't tell you to evaluate, so just leave it like that. And this is the same as just x to the 4th. Now, keep in mind that that is the base number, and 4 is the exponent number or the power number. Same thing, exponent or power. Okay, zero power property. Zero power property, any base except for 0 raised to the 0 power will always be 1. So like right here, it says 5 to the 0 power. 5 to the 0 power, if you type that into the calculator, it's going to give you the answer of 1. Anything raised to the 0 power is always 1. Even right here, it's x to the 0. Even though x is a variable, anything raised to the 0 power is going to be 1. But we have to keep in mind that right here it says any base except for 0. So on this one, x cannot equal 0. So look, watch. I'm going to type in 5 to the 0. 5 raised to 0 equals 1. I can type in 10,000 raised to the 0. Anything raised to the 0 will always equal 1. You guys have to memorize that. That by definition, anything raised to the 0 power is always 1. Now, the product of power properties. The product of powers, to multiply powers with the same base, you have to add the exponent coefficients are multiplied together. For instance, right here, you see how they all have the same base? 2 to the 3rd, 2 squared, 2. These all have the same base. So because they all have the same base, all you're really doing is you're going to add up the exponents. Okay, so now this has an exponent of 1, you just don't see it. So this right here is going to be a 2 raised to that. That's 3 plus 2, so that's 5 plus 1 is 6. That is actually 2 to the 6th power. Now, this is the reason why. The reason why is because how right here it says 2 to the 3rd power. I'm going to write the 2 3 times. So that's 1, 2, 3. I'm going to write this 2 2 times. 1, 2. I'm going to write this 2 1 time. So what does that mean? I have 1, 2, 3, 4, 5, 6 2's. Now let's see what the value is. 2 raised to the 6th, that equals 64. On this one right here, they have the same base. So make sure they have the same base. They both have a base of x. If they don't have the same base, you cannot add up the exponents. And then right here, 2 plus 5 is 7. I can't type that into the calculator because x is a variable. And the reason why this is x to the 7 is because here you have x squared, so that's 2 x's. Right here you have 5 x's, so that's 1, 2, 3, 4, 5. So what happens? You have a total of 7 x's. So when you have the same base, make sure that you add up the exponents. This next one, we have a 3x to the 5th, a 2x, and a negative x to the 4th. Once again, we have the x to the 5th, an x, and then an x to the 4th. Let's go ahead and let's just deal with the exponents first. So right here, there's a 1, you just don't see it. So 5 plus 1 is 6, plus 4 is 10. So that's 10 x's. So this is going to be an x to the 10 power. Now we're going to pay attention to what's called the coefficient. The coefficient is the number in front of the variable. So that is a 3 times a 2 times that's actually a -1. You just don't see it. So that's 3 times 2, which is 6, times -1 is a -6. If you wanted to write this out, that's 3x to the 5th. So that's 5 x's, 1, 2, 3, 4, 5. That's a 2, 1x. And then that's a negative and 4 x's, 1, 2, 3, 4. So look at 3 times 2 is 6 times a negative gives you the -6. And then you have 5 x's here, that's 6, plus another 4, that's the 10 x's. On this one now, if you notice, you have different variables. So look, you have a 4, you have 2 x's, and 1 y. Then I have a -3, I have 1 x, and 5 y's, 1, 2, 3, 4, 5. Then I have a -2, and I have 4 y's, 1, 2, 3, 4. If I just take my numbers and I multiply them, that's 4 times -3, which is a -12, and a -12 times a -2, that's going to be a +24. Now let's count our x's. I have 2 x's here. That gives me 3 x's, and that's about it. So there's 3 x's. Now the y's, I have 1 y right here. That's 2, 3, 4, 5, 6 y's, 7, 8, 9, 10 y's. So if it helps out, you can go ahead and write it all out. Or you can just add up the exponents. So just keep in mind, that's x squared, that's y to the 1, that's x to the 1, that's 5 y's, and that's 4 y's. Now go ahead and hit pause and try these ones on your own. I'm going to go ahead and I'm going to solve these. So on this one right here, I'm just going to add up my exponents. That's 2 x's there, 3 x's, so that's 5, plus another 4, so that's 9 x's. On this one, you have 2 times 4, which is a -8. Now your x's, you have 3 x's here, 2 x's here, so that's 5 x's total. Hopefully you guys got those ones right. Okay, let's go ahead and let's flip the page and go now to the power of a product. On this one right here, if you want, on the product of powers, we could go ahead and we could say like x to the a times x to the b. All you are doing here is if the bases are the same, you are adding the exponents up. So that's basically the general rule for products of power property. The bases have to be the same, and as long as the bases are the same, you add up the exponents. On this next one, we have a power of a product property. To find the power of a product, you have to find the power of each factor and multiply. So like on this case, how it says 2x to the 3rd power. Basically, this exponent is going to go to both terms on the inside. So this is going to be a 2 to the 3rd power and x to the 3rd power. And in this case, 2 to the 3rd, if I type that in the calculator, 2 to the 3rd, that equals 8. So this final answer is going to be 8x to the 3rd power. Now, this is the reason behind it. Remember we said that you write the base, the exponent number of times? So since the base here, the 2x's in parentheses, that is going to be a 2x times a 2x times a 2x. You write it 3 times. And 2 times 2 is 4, times 2 is 8, and then x times x times x, that's 3 x's. The general rule here, well, let's continue on, and then I'll show you the general rule. Right here, Look, you have 3xy raised to the fourth. Every single term on the inside is going to be raised to the fourth power. So that's 3 raised to the fourth power. X raised to the fourth power. Y raised to the fourth power. Everything is going to be raised to the fourth power. So let's see here. 3 raised to the fourth, that equals 81. So that's going to be 81, and then that's x to the 4, y to the fourth. And if you want, you could write 3x y to the fourth 4 times, and you'll still get the same answer. That's the reason behind it. Okay, this one, don't let the negative throw you off. I'm going to put every term in parentheses, and I'm going to raise it to the second power. So this is -3 raised to the second power, x raised to the second power, y raised to the second power, and z raised to the second power. So -3 squared, make sure you put that in parentheses because you need to square that negative value also. Parenthesis, -3, close my parenthesis. And now this calculator does have a square key, or you could go ahead and still hit raise 2. It'll still give you the same answer. Now the answer is a +9. And the reason why the answer is a +9 is because a negative times a negative is a positive. And then here you're left with an x squared, a y squared, and a z squared. Go ahead and hit pause and try to do these two. I'm going to go and solve them now. On this one, I'm going to put the -5 in parentheses, the squares on the outside, and then x is in the inside, squares on the outside. Make sure I'm putting my parenthesis, -5, close my parenthesis, and then I'm going to hit square. That equals a +25. So this comes out to be a +25 x squared. Here I'm going to distribute that cube to all 3 terms. So this is -2 to the 3rd power, x to the 3rd power, y to the 3rd power. Now, -2 to the 3rd power, that means a negative times a negative times a negative. So parenthesis, -2 raised to the 3rd power. That gives me a -8, which makes sense because there's 3 negatives right here. And then this is just going to be x to the 3rd, y to the 3rd. All right, power of a power. To find a power of a power, you have to multiply the exponents. On this one right here, what you are doing is you have to multiply the exponents. So I'm going to show you the reason why behind it first, just because it makes more sense. I'm going to write the 3 squared 3 times. So I'm going to write 1 time, 2 times, 3 times. Now on the inside, I'm going to write the 3 2 times. So this is 1, 2. I'm going to write that 3 2 times, 1, 2. I'm going to write that 3 2 times, 1, 2. So then this is basically 1, 2, 3, 4, 5, 6, 3 sixes. I mean 6 threes, sorry. So 3 raised to the 6th power, that equals 729. Now the rule behind this is you have to multiply the exponents. So you would keep the 3 there and you would multiply these exponents. So in the exponents, that'd be a 2 times a 3, and 2 times a 3 is a 6. And 3 raised to the 6th power is 729. So the rule behind this is, let's say I have an x a raised to the b power. You are multiplying these exponents. So this is actually going to be a times a b. So right here, how you have x to the 4 to the 3rd power, all you are doing is you are multiplying that. So 4 times 3, and 4 times 3 is 12. So this is actually x to the 12th power. Go ahead and write the x to the 4 3 times. That's 1, 2, 3. And if we use the first property, you could just add up the exponents. 4 plus 4 is 8, plus 4 is 12. And it still gives you x to 12. All right, next one. Now, this exponent, keep in mind, it has to go to each term individually. So this is going to be a -5 square, x square square, y third square, and then z square. Now, if I type that in the calculator, I'm going to type in exactly the way it is. Parenthesis, -5, close my parenthesis. Exponent is square. So that's going to be a +25. Now this rule, remember, you are multiplying these two. So 2 times 2, that's going to be an x to the 4th power. Right here, I'm going to multiply the 3 and the 2. So 3 times 2 is going to be a 6. So that's y to the 6th power. And then that's just going to be a z square. Go ahead and hit pause and try the next two on your own. I'm going to go and I'm going to solve them now. That square needs to go to each term on the inside. So that's going to be a 3 square and then x to the 4 and then square on the outside. 3 square, let's see, parenthesis 3 parenthesis square. That gives me a 9. And then right here with the x, I'm going to keep the base x and I'm going to multiply these exponents. So 4 times 2 is equal to 8. I'm going to distribute this square to 3 terms on the inside. So it's going to be a -4 and then square on the outside, an x and a square on the outside, a y cube and a square on the outside. -4 squared, so that's parentheses, -4 squared. That gives me a 16. So this right here is going to be a 16. That's going to be an x squared. And then right here, I'm going to multiply those because I have a power raised to a power. So 3 times 2 is going to be a 6. So hopefully you guys got those correct. Let's go ahead and let's flip the page. And now we're going to get into the negative exponents. So right here, we have a negative power property. A negative power, if you have a negative exponent, not a negative base number, a negative exponent, it's going to be the reciprocal of a to the n. So basically, that's going to flip to the denominator. And now that it flips to the denominator, it's now going to be a positive exponent. So right here, you have a 2 raised to the -3 power. That negative exponent flips it to the denominator. So this is actually going to be a 1/2. And now instead of being a negative third power, it's going to be a positive third power. That's all the negative exponent does, is it flips it to the bottom. Now in the denominator, 2 to the third power, that's 2 times 2 times 2, which is an 8. But let's see. Yep, it's 8. So this answer is going to be a 1/8. So basically the 8 is the denominator. On this one right here, you have a negative x. So right here, first I'm going to address this negative exponent. So that since that says a -4, I'm going to flip all of this to the bottom. So it's going to be 1 over, I'm going to put the negative x on the bottom. The -4 is what flips it to the bottom though. This -4 is what flips it to the bottom. And now instead of a -4 power, it's going to be a +4 power. Any questions on that? Well, not that I can answer them. April Fools. Okay, right here. Now, negative x to the 4th power. That means you're going to have 4 negatives, okay? If you're going to have 4 negatives here, a negative times a, so you're going to have a negative times a negative times a negative times a negative. A negative times a negative is a positive, and a negative times a negative is a positive. So your final answer is actually going to be a positive x to the 4th in the denominator. Okay, what happens if the number's on the bottom? Let's first address this negative exponent. This negative exponent is going to do the reciprocal. And the reciprocal, basically, all I'm going to do is I'm going to flip this. So basically, the 3 is on the top, the 1 is on the bottom. And instead of being a -2 now, it's a +2. Now go ahead and apply the exponent to the top and the bottom. So this is going to be a 3 square over a 1 square. Well, 3 squared, that's 3 times 3, which is 9. 1 times 1 is 1, so your final answer is 9. So because that negative exponent, these were in parentheses, that reciprocal applied to the 1 and the 3, so both of these had to flip places. On this one, it's a little bit different because the -4 only applies to the 2. So what this means is it's going to go into the denominator. So instead of it being a 2 to the -4 on the top, it's going to be a 2 to the +4 on the bottom. So basically that goes to the bottom. And then right here, how that says 3 to the -2, that's actually going to go to the top. It's going to be a 3. And then instead of a -2, it's a +2. Both of them both had negatives. That's why they flipped. If they didn't have the negative, they would stay where it was at. 3 squared, that's 3 times 3, which is 9. And then 2 to the 4th, let's see, 2 times 2 times 2 times 2 is 16. And that cannot be reduced. I want you guys to try the next two. I'm going to go ahead and I'm going to do them right now. So that's actually over 1. You just don't see it. So I'm going to go and I'm going to flip this. So that's 1 over -3. And now instead of that being a -2 power, it's going to be a +2 power. Now let's see, parenthesis, -3 squared, that gives me a +9. So +9 is the denominator. The negative exponent on this one's going to apply to both of these. So basically, both of these are going to flip. So now the 5 is on the top, the 2 is on the bottom. And instead of being a negative 2 power, it's going to be a positive 2 power. Now I can go ahead and I could do the exponent to the numerator and the denominator. 5 squared is going to be a 25. 2 squared is going to be a 4. I hope you guys got those right. Okay, let's go to the quotient now. A lot of rules. The quotient of powers. To divide powers having the same base, once again, it has to have the same base. You have to subtract the exponents as long as the base is not 0 and the exponents are integers. You can also cancel like factors from the top and the bottom. So the rule here is if you have x to the a power over x to the b power, you take the top power and you subtract the bottom. So the exponent will now be the top power, subtract the bottom. But remember, they have to have the same base. So like right here, you have a 3 to the 5th over 3 squared. Since they are both base 3, I'm going to keep the base 3. Now I'm going to take the top power 5 and subtract the bottom power 2. And 5 subtract 2 is a 3. And then let's see what 3 to the 3rd power is. 3 to the 3rd power, that equals 27. Now this is the reason behind it. 3 to the 5th power means you have 5 3s on the numerator. 1, 2, 3, 4, 5. 3 squared means you have 2 3s in the denominator. If you have multiplication, division have the same mathematical properties, so these 3s can actually cancel out. So what am I left with? I'm left with 3 times 3 times 3, which is the same as saying 3 to the 3rd power, which is 27. Right here, look at my bases are x's. So I'm going to keep the x. I'm going to take the top power 7 and I'm going to subtract the bottom power 2. And 7 subtract 2 is equal to 5. So that's actually x to the 5th power. Let me explain why. Here you have 7 x's in the numerator. 1, 2, 3, 4, 5, 6, 7. And then in the denominator, you have 2 x's. 1, 2. So these x's cancel, and look what you're left with. You're left with 1, 2, 3, 4, 5 x's. Right here. Now, the numbers are going to treat like normal. 2 divided by 3. 2 goes into 2 1 time, 2 goes into 6 3 times. So that's still going to be a 1 in the numerator, 3 in the denominator. Now, I'm going to go and I'm going to write this one out just because it's easier if you write it out. So on this one, I'm going to have a 1. I have 3 x's on the top, 1, 2, 3, and I have 2 y's on the top. In the denominator of a 3, I have 1 x and I have 6 y's. 1 x and 6 y's. 1, 2, 3, 4, 5, 6. So now this x cancels out, this y cancels out, and this y cancels out. In the numerator, I'm left with the number 1. You don't need to write the number 1, but I'm left with 2 x's, and those are in the numerator. In the denominator, I have a 3, and I have 1, 2, 3, 4 y's. I have 4 y's. So this was easier if I just write it all out. Because look, if you would have took the top power, 3, subtract the 1, that gives you the 2. If you would have took the top power on y, which is 2, minus 6, which is going to be a negative 4 power. So y the negative 4, which means it's going to be a denominator. I want you guys to try the next two. And let's see if you guys get it right. So right here, that's x. I'm going to take the top power, subtract the bottom power. So that's just going to be an x squared. This one right here, I'm just going to write it out just because I find it easier. So I have a 3, 1x, 2 y's. In the denominator, I have a 12, 3 x's, 1, 2, 3, and I have 1 y. One of the x's is going to cancel, one of the y's is going to cancel. And that's it on the variables. Now on the numbers, 3 goes into 3, 1 times 3 goes into 12, 4 times. On the top, I'm left with a 1y, which I'm just going to write as y. In the denominator, I'm left with a 4 and 2 x's, so that's x squared. Power of a quotient. To find the power of a quotient, you have to find the power of the numerator and the power of the denominator, then divide. So right here, that exponent is going to go to the top and the bottom. So this is going to be a 2 to the 3rd power on the top and a 5 to the 3rd power on the bottom. So let's see here. Parenthesis 2 raised to the third power. That gives me an 8 in the numerator. And then I have a parenthesis 5 raised to the third power. That gives me a 125 in the denominator. On this one right here, I always throw the negative on the top. I always throw the negative on the top. So this is going to be a negative x raised to the fourth power on the top. And then it's going to be a y raised to the fourth power on the bottom. Now think about it. On the top, you have a negative times a negative times a negative times a negative. Two negatives make a positive, two negatives make a positive. So this answer is going to be actually a positive x when it comes out. And then that's just y to the fourth power. On this one, the cube, I'm going to apply that to every single term. Now, I always throw the negative on the top. So I'm going to write that as a negative 2 to the third power. Negative 2 to the third power. I have an x squared to the third power, and I have a y to the third power. Then I'm going to have a 3 to the third power and a z to the third power. Now, on this one, negative 2 to the third. Let's plug that in the calculator. Negative 2 raised to the third power. That gives me a negative 8 in the numerator. So that's negative 8 right there. When you have a power raised to a power, you are multiplying those. So 2 times 3, that's going to be an x to the 6 on the top. And then that's going to be a y to the third. Now, 3 to the third power. 3 raised to the third power. That gives me a 27. And then I have a z raised to the third power. All right. I want you guys to try the next two. And let's see if you guys get those right. I'm going to go and I'm going to solve them now. I'm going to apply the square to the top and the bottom. So that's going to be an x square in the numerator and then a 3 square in the denominator. On the top, that's going to be an x square. In the denominator, I have a 3 square, which is a 9. And then that cannot be simplified. Sometimes on multiple choice tests, this might actually be written as a 19x squared. That's the same thing, okay? That's the same thing. On this one, I'm going to apply the square to everything. I always throw the negative on the top. So that's going to be a negative 2 square, an x square, a y cubed square. On the bottom, that's going to be a 5 square and a z square square. Negative 2 in parentheses square, parentheses, negative 2 parentheses square, that gives me a 4. So this is going to be a 4 right here. That's just going to be an x square. And then on the y, remember you are multiplying these exponents. So 3 times 2 is going to give me a 6. So that's y to the 6th power on the top. In the denominator, 5 squared, that's 5 times 5, which is a 25. And then right here, you're going to multiply those exponents. So 2 times 2 is going to be a 4. So then that's z to the 4th power. Now, the last part of the notes, rational exponents. On rational exponents, the nth root of a is the real number and m is called an integer. So basically right here, this is called the power and this is called the root. The denominator is the root. So look at how the root is 9. That's what's going to go on the square root. Okay. And then it has a power of 1. You just don't see the 1 here. So on this one, 1 is going to be the power. 2 is going to be the root. So basically, the way you rewrite this, since the power is 1, the power goes on the inside, and then 2 is the root, 2 is on the outside. That basically means you need 2 of the same numbers to come out, okay? So what times what gives me 36? The answer is going to be 6. Now, the way that you can type this in on the calculator is here's the root button, and because it's in this like bluish color, you're going to hit second, and then hit that key right here, which is the x squared key. That's going to be the square root. And then I'm going to hit 36. I don't have to put the power of 1 and look at the answer 6. A lot of you guys learned this by the factor tree. That's basically 6 times 6. The minute you have 2 doubles, it comes out. I need 2 of them to come out because that's the root part. Right here, this is the power. This is the root. So you have a 100 raised to the 1/2 power. So right here, I'm going to go ahead, I'm going to write 100. The power is 1, the root is 2. So once again, I'm going to hit the second button, and then I'm going to hit this square root button. So that's the square root key. Automatically, there's no number there. It's going to be a 2. Sorry, let me turn on the light really fast. And then I'm going to hit 100, and that gives me 10. This is actually 10 times 10. So that's why you have 2 doubles. So that's why it's going to come out. You can also type in 100 raised to the 1/2 on the calculator. The way to do that is you would have to hit 100, and then you would hit the raise key like an exponent. Now, you need the 1/2 all to stay together. So that would actually have to go in parentheses. 1 divided by 2. And look, that gives you 10. You can even use the fraction key on here. The fraction key is the ABC key. Look at 100. I'm going to hit the raise key, parenthesis. I'm going to hit 1 ABC 2. That's the fraction key. And look, it still gives you 10. Here, you have 3 raised to the 1/3 power. The 1 is the power. The 3 is the root. So the 3 is going to be the root part, and then the 1 is the power. So with the root of 3, you need 3 of the same number to come out. So right here, 8. 8 breaks into a 2 and a 4. The 4 breaks into a 2 and a 2. When I broke that 4 apart, that went away. And look, 2 times 2 is 4 times 2 is 8. You need 3 of them to come out. Well, guess what? I have 3 of them. So the final answer is going to be a 2. Now, let's say I type this in the calculator. Okay, I'm going to hit 8 raised to the 1/3. Look. 8 ABC, I'm going to put a parenthesis, 1 divided by 3, that's my 1/3, and look at the answers 2. You can also use this right here, that key. If you notice it says X and then a root, that means you have to hit the 3 first and then that power. So another way you could do it to type this in is I'm going to hit 3, I'm going to hit the second key, and then I'm going to hit this raise 1. So what it does is it automatically puts the 3 where the where that X is at, where the root's at. And then I'm going to hit the number 8. And look, I still get the number 2. Or you could type it in exactly like this, 8 raised to the 1/3. All right, let's go ahead and let's try these. I'm just going to type these in the calculator. So this is the same as saying 25, and that's a square root. And the power is 1. 1 is the power, 2 is the root. Square root of 25, and that gives me a 5. Right here, that's 25 raised to the 1/3 power. So 3 is the root, and then 27. So I'm going to hit 27 raised to the 1/3 power. 1/3 power. Make sure that that's in parentheses, and that answers 3. If you want to use the root key right here, I'm going to hit 3 root first, 3 second, arrow up. So that puts the 3 where the root's at, and then 27, and there's your answer. Your answer is still 3. And that concludes our notes.